In this video, we're going to be learning how to use common factors to simplify fractions and how to use common multiples to express fractions in the same denomination. You have a variety of activities on your worksheet. First of all, we'll be learning the basic skills, and then we're going to be applying them to a variety of different activities and then word problems. The first activity on your worksheet is some simplifying. So you have some fractions which you need to simplify. If you feel confident with doing this already, then give it a go. If not, stay and watch the video and we'll go through some examples. When simplifying fractions, you are basically finding equivalent fractions, but you are finding the smallest equivalent fraction, or the equivalent fraction with the smallest numerator and denominator that you can find. Let's have a look at some examples. So I have 5 fractions and I want to find the simplest equivalent fraction. So to find my simplest fraction, I need to be thinking about common factors. So I want to think about my 6/15 to begin with. I need to think about what number I can divide both my numerator and my denominator by. So I'm going to think about the largest common factor for both numbers. So what I might do is to start with a list. You might actually just recognize numbers that you can divide these numbers by, which is absolutely fine, but I'm going to work through systematically as if you had no idea how to do this. Let's start with making a list of the factors of 6. We have 1, 2, 3, and 6. And next we need to make a list of our factors of 15. So we'll start with 1, we have 3, we have 5, and we have 15. Okay, I can see that there is a common factor there. It's 3. Both my numerator, which is 6, and my denominator, which is 15, can both be divided by 3. So I'm going to divide both of these numbers by 3. So divide my 6 by 3, I get 2. Divide my 15 by 3, I get 5. When I look at my number, my fraction now 2/5, there are no common factors of 2 and 5. 2 only has a factor of 1 and 2, and 5 only has a factor of 1 and 5. If I divide both of them by 1, it's going to stay exactly the same. Okay, so I can leave my list of factors for 15, as I'm going to need them again when I calculate the simplest fraction of 9/15. And now I can also make a list of my factors of 9. I have 1, I have 3, and I have 9. Both of these numbers can be divided by 3. It is important that you find the largest factor. So 9 divided by 3 is 3, and 15 divided by 3 is 5. Okay, I know that that number cannot be simplified anymore because there are no common factors, and in fact 3 and 5 are prime numbers, so they don't have any factors other than themselves and 1. If you had a fraction where both the top and the bottom were both even, then you know that they can both be halved. And sometimes you can keep halving your fraction till it gets as small as possible, and then just check for any other common factors. So let's look at our 7/21s. So I'm going to make a list of my 7s. Well, 7 is a prime number, so it only has 1 and 7. 21, however, has a few more factors, but we can see that there is a common factor of 7. So I'm going to divide both my numerator and my denominator by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. So 7/21s is it's equivalent to 1/3, and 1/3 is the simplest version of 7/21s. Okay, let's look at my 9/36 now. Let's make a list of 9, 1, 3, and 9. And now let's make a list of 36. It's got a lot more. 1, 2, 3, 4, 6, 9, 12, and actually it does go on, there's 18 as well, but the largest one, factor of 9 is 9, so that's going to be the largest common factor. So I can divide both my numerator and my denominator by 9. 9 divided by 9 is 1, 36 divided by 9 is 4. So 9/36 is actually equivalent to a quarter. Finally, I've got my 24 80ths. Now, we're going to list our multiples, but I can notice that these are both even numbers, so I could actually just halve 12, 40 until the numbers become a bit easier. I could halve that again, halve my 12 and my 40. I'm going to get 6/20. Halve that again. I'm going to get 3/10. Okay, I can't halve it again. My 10 will halve, but my 3 won't. And we cannot have a part number, a decimal or a fraction number as a numerator or a denominator. The numerator and the denominator both need to be whole numbers. Okay, interestingly, 24 and 80 are both also in the 8 times table. If I divide 24 by 8, I get 3. If I divide 80 by 8, I get 10. 3/10 is the smallest, it's the simplest version. I also know that can't be simplified because 3 is a prime number. Have a go at the activity on your sheet now. For the next activity, you need to think about whether the fractions are represented in their simplest forms already. So it's a true or false activity. Are each of those fractions already in their simplest forms? This is a great skill to practice because in many questions you're asked to simplify a fraction, and if you're able to recognise whether a number is in its simplest form, that will stop you from making any errors. Okay, 6/10, is it in its simplest form? Well, we can see that they're both even numbers, so we know that actually they can both be halved. Can 3/5 be simplified? Well, 3 and 5 are both prime numbers. They can only be divided by themselves and 1. So 3 and 5, they don't have any common factors. Therefore, 3/5 is the simplest. And this answer would actually be false anyway, because 6/10 was not in its simplest form. Let's have a go at another example. Is 6/25 in its simplest form? Well, they're not both even numbers, so I can't halve them. Do they have any common factors? Neither of them are prime numbers. They do have factors, so let's make a list. Let's make a list of 6. 1, 2, 3, 6. Those are my factors of 6. Now let's make a list of the factors of 25. 1 and 5 and 25. There are no other factors of 25, and you can see that there are no common factors apart from 1, and if I divide both by 1, it's going to stay the same. Therefore, this actually is in its simplest form, so it would be a true. Let's have a go at another one. 8/32s. Okay, well, it's an even number. I can see that straight away, so I know it can both be halved. So actually, I already know that this is a false. Okay, it can both be halved, so I know it's a false. But let's have a go at trying to simplify it anyway. We could either think about the highest common factor, or you can just keep halving it. 4/16. My 4/16, both even numbers, so I can halve it again. 2/8. Both even numbers, I can halve it again. 1/4. And now that would be my simplest version of that fraction. So that one was a false because it was not already in its simplest form. So let's have a go at one final example. We have 7 22s. Is this in its simplest form or not? So I might start by listing my multiples of 7 and listing my multiples of 22. They're not both even numbers, so I can't halve it, so I do need to list my common factors. I might spot that 7 is a prime number, so I actually know if I listed the factors, you would soon figure this out anyway, because those are the only two factors of 7 because it is a prime number. So therefore, 22 needs to be divisible by 1 or 7 for us to be able to simplify it. We know it divides by 1, but it won't stay the same. And 7 is not a factor of 22. I'll write the factors out just to prove it. These are all the factors of 22. There are no common factors. This is in its simplest form already. So that is a true. So give the ones on your worksheet a go. Remember to work through systematically. If both the numerator and the denominator are even, you can just keep halving. Once you've got to a point where you can't halve the numerator and the denominator, can you recognise any common factors? If you're not able to recognise the common factors straight away, then make a list of the multiples of both numbers and then look for any common factors and then divide both your numerator and your denominator by that factor. Okay, good luck. Give that one a go. Okay, in this next activity, you are going to be matching the equivalent fractions. So you're going to be thinking about which set of fractions, which pairs of fractions are actually equivalent. To do this, you're going to be needing to use your understanding of multiples and factors. Okay, remember, whatever you do to the numerator, you must also do to the denominator if you want to find an equivalent fraction. So we're going to look at 3/5 first, and let's have a look at this fraction here. Now 5 does fit into 50. 5 is a factor of 50 and 50 is a multiple of 5. 5 fits in 10 times to 50. So therefore I would need to multiply that by 10. 3 would need to fit in 10 times to 40 and it doesn't. So that is not an equivalent fraction. We know that that one doesn't work. Let's have a look down here. 5 is a factor of 60. It fits in 12 times. Does 3 fit in 12 times to 24? It doesn't, so that one doesn't work. We've only got one left, but we need to check it works. 5 fits into 30 6 times. 3 also fits into 30 6 times. So this one in fact works. Okay, let's look at our next one now. Let's now look at 8/10. Well, 8 actually fits into 40 and it fits into 24. Let's see which one has the equivalent fraction. So 8 fits into 40 5 times. 10 fits into 50 also 5 times, so that one actually works. So 8/10 is equivalent to 40/50. So we've got 2 left. Let's just double check it works. 2 fits into 24 12 times, and 5 does also fit into 60 12 times, so that one is correct. And we have found our equivalent fractions. So give it a go on your worksheet. Remember to check that the numerator and the denominator both fit into the other number an equal amount of times. So if you've had to multiply the numerator by 7, say, then you would also have had to have done that to the denominator. Okay, so give that one a go. In the next activity, you're finding a variety of equivalent fractions. We're still using our understanding of factors and multiples to help us find the equivalent fractions. But in these examples, you're given the numerator and you need to use that clue to find what the denominator will be. Let's have a look at an example together. Okay, I have 3/5. I know the numerator of my equivalent fractions, but I don't know the denominator. So the first thing I need to do is be thinking about my multiples and my factors. I need to think about 3 and 9. 3 is a factor of 9. How many times does 3 fit into 9? Fits in 3 times. Therefore, I would also need to multiply my denominator by 3. So 3/5 is equivalent to 9/15. Okay, let's go to the next one. 3/5 is equivalent to 15 watt. Well, let's think about how many times does 3 fit into 15? It fits in 5 times. I therefore need to do the same to my denominator. 5 times 5 is 25. Remember to pause if you need to rewind and listen again, it's absolutely fine. Okay, now let's go on to our next one. 3 into 39. If you're not able to see or do this mentally, use a written method. How many times does 3 fit into 39? Well, I'm going to use my bus stop method. 3 fits into 3 once. 3 fits into 9 3 times. So it fits in 13 times. So I need to also multiply my 5 by 13. Again, you can use a written method for this. You could also multiply 13 by 10 and then halve your answer. But let's go through this version. 3 times 5 is 15. 1 times 5 is 5. Plus your 1 is 6. If you had it done the other way, 13 times 10 is 130. Half of 130 is 65. Okay, and our final one. 3 into 14. Okay, if I know that 3 fitted in 13 times the 39, I can actually see that 42 is just 3 more. So it must fit in 14 times. However, if you're not sure, use the bus stop like we did earlier. 3 into 4, once, with a remainder of 1. 3 into 12, 4. Okay, so I know that I also need to multiply my 5 by 14 to get to my answer. So again, you could do 14 times 10, which is 140, and then halve it, which is 70. Or you could do a written method. 4 times 5 is 20, 1 times 5 is 5, plus the 2 is 70. Both reach the same answer. You need to use the method that you feel comfortable with, that you can do it accurately. Okay, give the examples on your worksheet a go. Remember to do it methodically. Think about how many times the numerator fits in, and then apply that same thing to the denominator. In your final activity, you have got some word problems involving fractions, and you are asked to leave your answer in its simplest form. If you feel confident, go ahead now. I'm going to go through the first 2 questions which are on your worksheet. So if you'd like a bit of assistance with the first 2, or perhaps even just the first one, then follow on with the video now. Otherwise, pause and give your worksheet a go. So our first question, Lisa filled 6/8 of her sticker book. How much did she have left to complete? So to be able to answer this, you need to have an understanding of a whole. So if 6/8 is part of her sticker book, how many eighths would equal the complete sticker book? So you should know that the whole sticker book would be 8/8. Okay, when the numerator and the denominator are the same number, that is equal to 1. Okay, so I'm going to write here 1 whole. The whole sticker book would be 8/8. Lisa has filled up 6/8. Okay, so I need to do 8/8 minus 6/8 because this is telling me what the difference is. What's the difference between 8/8 and 6/8? I can subtract these because they have the same denominator. So 8/8, take away 6/8. Well, she's got 2/8 of the sticker book left to complete, but I need to leave my answer in its simplest form. So I need to find a common factor to divide both 2 and 8 by. Now, the first thing I'm going to do is I'm going to notice that actually 2 and 8 are both even numbers, so I can just halve them. Half of 2 is 1, half of 8 is 4. I cannot simplify that anymore. The simplified answer is 1/4. If you're feeling confident, then give the next question a go. You can always then join back in if you get stuck. If you still need a bit of help, then stay tuned and we'll go through the next problem. The Robinson family used up 8/10 of fuel on their family road trip to the south of France. How much fuel did they have left? So again, you need to know how much fuel, how many temps there are in the whole tank. So remember what we said in the last question, when the numerator and denominator are the same, that is equal to the whole. Okay, that's all of it, that's all of the fuel. So they started out with 10/10 and they've used 8/10. Okay, so what have they got left? Well, 10 take away 8 is 2. They have 2/10 of their fuel left, but I need to write that answer in its simplest form. Okay, again, my 2/10, both even numbers, so I can simply just halve the top and the bottom. Half the numerator is 1, half the denominator is 5. I've got 1/5. That cannot be simplified anymore because I've got a 1 as a numerator. I can't simplify my 1. I can't reduce that in size anymore. So my answer to that question in its simplest form is 1/5. So have a go at the next couple of questions. Think about what a whole is, write it out systematically, get your answer, and then think about how you can simplify your answer. What common factors are there? Are they both even numbers? If the numerator and denominator are both even numbers, then you can just halve it. Well done, you've completed the activities on using common factors to simplify fractions and using common multiples to express fractions in the same denomination. So print out your past SATs questions and have a go at answering these type of fraction skills in a SATs question format. There will be tons of questions on fractions in your SATs paper, both in your arithmetic paper and in both of paper 1 and paper 2. And these fraction problems can be written in lots of different ways. So give it a go and see how you fare. Good luck.